We'll discuss here the equation of a hyperbola that is obtained by vertical and or horizontal shift of the hyperbola with center at origin. We'll consider here the case where the foci are on the x-axis. We'll work first with a specific example before we'll discuss general properties. So suppose we have a hyperbola x squared over 1 minus y squared over 4 is equal 1. The graph of that hyperbola is given on the left. Suppose we want to shift this hyperbola in such a way that the center is now at the point 3 and 2. We are moving the center 3 units to the right and 2 units up. How will the equation change? How will the coordinates of the foci and vertices change? So since we are moving 3 units to the right, we'll have to replace x with x minus 3 in our equation. So we'll have x minus 3 instead of x divided by 1. And then we are moving the graph 2 units up, so we have to replace y with y minus 2. These are the only changes to the equation that will occur. And the amounts of shift are indicated by that differences x minus 3 and y minus 2. How will the coordinates of the foci and vertices now change? Again, we are shifting 3 units to the right, so we'll be increasing the x coordinates by 3. And since we are moving 2 units up, we'll be increasing y coordinates by 2. So if the vertex had coordinate 1 and 0, now it's going to be 1 plus 3 and the 0 plus 2. And therefore, the coordinate of that vertex are going to be 4 and 2. The same with the point negative 1, comma 0. The new coordinates or coordinates of the vertex are going to be 2 and 2. For the foci, to find the coordinates, we'll do the same. We'll increase the x coordinate by 3 and we'll increase the y coordinate by 2. For the second focus, we'll have negative square root of 5 plus 3 over 2. Now, when shifting a hyperbola, we have to shift also the asymptotes because they determine the behavior of that hyperbola. So if I want the equations of the asymptotes, I will just look at the original equations of original asymptotes and change them in the same way I change the equation of a hyperbola. So we'll replace y with y minus 2 and to replace x with x minus 3. Those equations will have to be written in the slope-intercept form later on. So once we have this example, we can generalize this to the situation where we are moving, we are shifting a hyperbola with the equation x squared over a squared minus y squared over b squared is equal 1 in such a way that the center is now at the point h and k. We'll change the equation accordingly, taking into consideration amount of shift and direction of that shift. And we'll change the vertices in the same way once we determine what's happening to our coordinates depending on the values of h and k, whether the coordinates are going to increase or decrease, and we'll change them accordingly. In the same way we change the equation of the hyperbola, we change the equations of the asymptotes. The graph of hyperbola is going to be obtained by simply shifting it 3 units up and 3 units to the right and 2 units up. So the center has been already transformed. Now the vertex v sub 1 moves to the 4 and 2, vertex v sub 2 moves to the point 2 and 2. The asymptotes will change as well, will be shifted, so this would be the one of them, and the other one will be right here. We can choose 2 points on them and shift those 2 points and draw the asymptotes. And now we can draw the hyperbola. Notice that for this hyperbola, the vertices now are on the line parallel to the x-axis. In the same way we discuss hyperbolas with foci on the x-axis, we can approach hyperbolas with the foci on the y-axis. Really, the only difference is the form of the equation. Now our equation is y squared over a squared minus x squared over b squared is equal 1, and it's going to change into y minus k squared over a squared minus x minus h squared over b squared is equal 1. But the approach is exactly the same. Once we determine values of h and k, we'll change the coordinates of vertices and foci accordingly, and the equations of the asymptote are going to be changed in exactly the same way as the equation of the hyperbola.